there's no homework due today, right? Homework due tomorrow. Last night was to start. We didn't get super far, so I'm not going to spot check that starts today. That's probably coming soon. We ended on this example number 3. Do you remember what the page, it should be yours. What was the page before? Like what were we writing about right before this example? Translating. Good. We were translating. I was trying to pull you guys away from being so focused on y and x. Do you remember why I was doing that? I gave you a few reasons. I didn't have you write them, but list them. Why would I try to pull you away from being so stuck on who's y and who's x? Yeah.
The word problem will use X and Y.
Yeah, maybe sometimes the word problem won't use X and Y. It can use something different like letter A. Who's my Y?
Height.
Not in letter A. V, good. Volume is my Y. Now, how could you know that? Are you guys looking at the translating? Look at what we wrote in our notes. Translating. How do we know that volume has to go with y, or the output, or the dependent variable? How do we know volume has to go with that? Yeah.
What is the function of height?
Good. Look at the wording. Whatever's in this spot. Blank is a function of blank. What's always going first? Look at your translating. The y always goes first. Do you guys see the wording of as a function of? Right? So find that and say, oh, function of, who's before that volume? That's my y. Y equals v equals. And as a function of who? And what always comes after as a function of, or dependent on, or x always comes after. So I knew r had to be my x. Now we're going to see later today, we haven't technically reviewed in this class function notation, f of x. But I'm starting to use it just a little early to show you volume as a function of r, which would be similar to what you guys have seen before, as y is a function of x. You've seen that before, yeah? All that's different is now we have a v and we have an r. Okay? Now, remember yesterday I was telling you how to shorten this whole thing, and we said, okay, you can for iced tea, slightly narrower, taller than the standard. H over R is 4. This is what I call in a word problem a clue. And then I said something at the very end. Oh, we actually wrote it down. I forgot. We were ahead of period 5. I said we need to go back to geometry. Sometimes in math it assumes, for instance, if you have an equation, like, let's see, what would be a good one? Ooh, you guys hated the football field one, right? Wasn't that the one you guys all hated? Yeah. And some of you just gave up on, we had that whole talk about whether to use it or here and try and look at count chat and use it wisely. Didn't it talk about the perimeter of the field? Or did it give you the formula for the perimeter? Why? It assumed that you either know it or you can go back and find it pretty quickly. We all have phones. What's the perimeter of a rectangle? Oh, right? So, same thing here. It didn't give you the volume formula for a cylinder. You've done that before. It assumed either you would remember it or you could go find it. Volume is pi r squared h. Do you remember how I explained this yesterday? How volumes work of geometric solids? What was this part? It's circle, area of a circle. And what shape is a circle in a cylinder? Isn't it the base?
Yeah.
So we can say area of the base times the height. Takes the second dimension, just like a circle, and times the height makes it go all the way up through and get the volume. Anyway, that's how volume formulas work, in case you forgot. But we need to go ahead and figure out how to answer letter A. That's when it starts to work. What variables? In letter A, what variables or what variable does it want exclusively in the function for volume? Just radius. Only radius. There can be numbers, there can be powers, there can be other parts, but the only variable that's allowed to be there is radius. So what's the problem with our current formula? There's radius and height. So, if they want us to get volume as a function only of R, we need to get rid of who? Like, how do we ever get rid of something in math? Just randomly go in and take it out and be like, oh, well, hope it didn't mess things up. Would you do that to a car? Go take out the spark plug and be like, it's okay, keep going. No, if you take out something, what had you better do? Plug something back in, right? Okay, so if we take out H, we have to plug something in its spot that is equivalent. Does anybody see a piece of information that we haven't used? How can we use this to help us get something to substitute for H? Couldn't we take this expression, and before we even finish A, couldn't we say, well, if H over R is 4, then this little double arrow in math means this implies, it's kind of a way of going to the next step without just like leaving a space. Then we can multiply R to the other side and say H is equal to 2. Can we multiply this side by R? The R's cancel. Multiply this side by R and we have 4R. Now, do we have something to substitute for H? Yeah. So let's go ahead and go to our formula that we have over here. Let's say, okay, taking this piece, we can go ahead and plug in and say, okay, volume equals pi r squared what? 4r. Plug it in, take out the h. Take out the h and put in the 4r. 4r is substituting for our h. Now, if we want to be super snazzy, I mean, we're good math students, right? So would we leave it looking like that? Now, what's the proper way of simplifying? Who always goes in front if we can put him in? The number or the coefficient. So this is just times. It'd be pi times r squared times 4 times r. The 4 can come in front. Multiplication is commutative. I can rearrange. 2 times 3 is 3 times 2. 2 times x is x times 2. I can move 4 in the front. Pi is going to chill there because he's a coefficient too. Because he's a number, right? 3.1415926. What's going to happen with my r's? Yeah, r cubed. Do I now have a function for volume in terms of only r? Yes. And some of you that are like, no, there's a 4 and there's a pi and there's a cube. No. What's the only variable in this side of the equation? R. Good. I have volume as a function only in terms of the variable r. All the rest are like coefficients and powers, and that's okay. I want you guys to go ahead and read letter B. Figure out what they want now. Volume as a function of. Go back to our volume formula and go back to our clue and see if you can figure out a way to get there. I'm going to give you 2 minutes of individual work. I'm going to have you quickly collaborate in groups and see if you can bring it all in together, and then we'll talk about it as a class. Ready, set? Need the wording. Try to fill in what they want volume as a function of. Go back to the volume formula. Go back to the clue. How can we use it? It's very similar to what we did just up there. What have you filled in so far? What do you think you're supposed to do? Go ahead and turn.
Ali, where'd it go?
Try to show in your notebooks too if you've done something. Sometimes words are hard to teach.
That's what I do. I don't.
I didn't think so. Is it? I want to. What did you write? No, I just, I put the H.
Yeah. Yeah. I was like,
I didn't know what you just said. Like, whatever you were like, carry cards.
I do the same thing.
Your groups are totally stuck. Just slowly start filling in things. Your groups are totally stuck. I'm going to slowly start filling in things.
I think I don't think you can do anymore.
What do you think so far? What have I done with my clue? What have I solved for? Now, how did I solve for R, just in case you got lost? What was the first step I did? How did I go from here to here? Good. I multiplied both sides by R. If you need to see it, I can show the work right over here. I multiplied by R, right? And I got H alone. But did I want to plug in for H? Do I want to get rid of H this time?
No.
I want to get rid of who? R. So I need to go ahead and say, well, that's great and all. H does equal 4R, but I need to solve for R. So what did I do next to get to the next statement? I divided both sides by 4. Right? Then I got R alone. Now, are there multiple ways of doing this? And the answer is yes. You could have also put the 4 over 1 and done cross multiplication, which is kind of the same thing. I guess you could have flipped both sides and made it R over H equals 1 over 4 and then solve for R. But the problem is, if you, but you wouldn't be done. Because if you did, it's a great thinking. It's great thinking, but the problem is the following. Super common mistake. If you multiply by 1 over H, H is canceled. 4 over H is on this side. What's on that side? Super common mistake. All the time. All the time it happens if you try it. So good thinking. But how would you get to the final answer? You guys see it, right? Flip it and flip it. Flip it and flip it. So you could go ahead by flipping both sides or by doing 1 over both sides. You would end up with the H over 4. Most people, though, this is probably the easier process to follow. I would say the left side is easier to follow. Now, am I done once I got R by itself? No. But what am I going to do? I'm going to go to my volume. If you need, I'll go ahead and write it again. Go to my pi r squared H. I need the H to stay, and I need who to go? The R. So I'm going to plug in for R. Which is why my next step would be V equals pi who squared? H over 4 squared. Plug it in, the R squared times H. Now, being a good math students, hopefully we're trying to be. Not perfect, remember, be real, but good. We would need to simplify. When you multiply, or when you square H over 4, isn't it H over 4 times H over 4? So H is being squared, and 4 is being squared. Some of you might get a little confused with this little H is by himself, but if you think about him as over 1, just a few of you that are scared of fractions, and that's not a bad thing, it happens. You can make this H over 1. Then it might help you for the next step where we can say there's H squared and another H. How many H's total? Okay. The pi is going to go in front, and technically, to be super snazzy, this is very similar to what you guys were looking at here with the 1 over R. what would we pull out for the number in front? 16?
116.
116. Because the 16 is in the denominator, the 1 is in the numerator. So we need to have 116. Another way of writing it is you could have just done pi h cubed all over 16. Either one is good. You don't have to have both. Either one is good. Both of them mean the same thing. But the same way that you guys tried to take the creative way, there's some jobs over here. A lot of people would pull that 16 out, so I'm glad we talked about it, because that 16 is a 116. That's a common mistake. Same mistake, just in different ways. Alright. Can word problems get kind of hard? Yes. What you need to be careful of before you ever even start, really, any type of word problem, what do you need to be careful to do? What's the first thing that we did before we even got down to it all? Read the directions, read the givens, the problem, and summarize what's important. If we hadn't pulled this out, would we have been able to do anything?
No.
So we have to read carefully and pull out. And if you can, write it as a mathematical statement. That helps your brain see, ooh, it's an equation, maybe I should use it, right? Then we have to read the direction, what the actual problem is it's asking us to do, what they're directing us to do. Try to put that as a math statement, and then try to apply it maybe even to some old math that they didn't even tell us. But maybe they give us all the equations in the problem itself. Anyway, example number 3, let's move on to some stuff that's a little bit away from the word problems, but question, could the word problems be a little tricky and lengthy? Yes. But I see huge paragraphs in your homework. No. But do I want you to read it carefully and summarize the important stuff we're doing? Yes. Does that make sense? It's all trying to help, I promise. Very little of what I do. Very little. It's just for busy work. Everything has a purpose. At least I try. Domain and range. Domain and range. There's one. I have an example of a graph over there on the page. On the page. On the whiteboard. Big page. Anyway, I have an example of a graph over on the whiteboard. We're going to get back to that in just 1 second. Before we do, we are dealing with domains and ranges of equations, but if you can get the idea of domain and range on a graph, it'll help you with the equations, okay? I want you guys really quickly to orient yourself with what domain is, okay? According to the definition right here above me, my little highlighter up. There he is. Domain is the set of all possible what types of values? Who are you? Go away. Hi, Brody. I think I hit the weird magical. Okay. Try again. All possible x values. Okay? All possible x values. Question. Is x the horizontal axis or the vertical axis? Okay. So I'm looking for all possible horizontal values. Now, here's a silly, I know it's kind of dumb, it was the way I think that my Algebra 1 teacher taught me, it's the way I taught my Algebra 1 kids when I used to teach Algebra 1 a few years back. Domain X. My mom was a secretary in a doctor's office for a few years, and so I don't know if any of your parents work in the medical field, and she always get like from the drug reps, like all the pens and the notepads and all the random stuff they bring home. Anyway, it always reminded me of something that would go on one of like those pens that she would bring home. Domain X. What is the point of memorizing domain X? Domain goes with what kinds of values? X. Well, if I'm doing that with domain, what do you think I'm going to do with range? Oh, that's boring. Range needs a little bit. Right? Okay. So, domain X and then range Y works too. If you don't want that one. Anyway, domain X and ranging. I know it's dumb. It's a way of remembering it, whatever. Maybe you don't need a way of remembering it. So, we have domain X and ranging. I want you guys to look over here on this graph. And if I'm looking for all possible X values on the graph on the board, my question to you is, first of all, is the domain restricted? How do you know it's restricted? Look at the graph. If it's all the horizontal values, how do you know that the domain is restricted? Could it be helpful for thinking about domain? Think about how left to how right. We're actually going to put this in our notes a different day in a different section. So if you want to write it now, you can to help you remember. If you want to write it later, you can as well. But you want to ask yourself the question, how far left does it go horizontally? How left does it go to how right does it go? And so those of you that were like, yeah, I think it's restricted, can we answer that better? How far left does it go? Yeah, I did put a negative on, apologies. To the -3, true?
Yes.
So it is restricted. It doesn't go to negative infinity. It doesn't go forever. It doesn't go forever left, right?
Yeah.
Correct? Okay. So what inequality could I give that would describe how far left it goes and how far, well, we didn't answer that. How far right does it go? Infinity. So how can we put that in an inequality? What would my domain be? Is it for right now? It's okay. It doesn't say the time? Uncertain. That's what I'm looking at. Oh, you still. Sorry, some other concept. How right, how left. It goes all the way down to -3 and can be anything greater than. So x is it greater than or greater than or equal to? Because the dot is filled in. Okay. Now, if that's domain, let's come back up here really quickly. What if you have a function, not a graph? What if you have a function? Really quickly, if someone's watching this, you're not in class today, the example that we have, 1, 2, 3, looks something like this. And I think it goes up to, is that right? Technically, if you guys want to know what function this is, it's a square root function that's been shifted left 3 and up 2. But that's my f of x, and we just talked about how the domain, looking at it, how left did it go? -3. How right does it go? Forever. X is greater than or equal to -3. That's what we're doing when we have a graph. Okay, if we have a function, there are two different ways two different ways of thinking about domain. One is that they could give you a function like f of x is equal to x plus 2. And this should remind you kind of like piecewise functions. For 1 less than x less than or equal to 8. What's the domain of that example? Yeah, the inequality they already gave you. It's given. Sometimes they just give you and say, hey, this only works here. That's it. You're like, okay, fine, it works there. That's the domain. That's it. But implied, another way of saying implied domain is also saying implicit. I think it's one of your vocab questions tonight. Implied domain or implicit domain is when you have to look at the function and figure it out yourself. Like, can I give you the equation for the graph that we just worked with? The equation for that graph would be 2 plus the square root of x minus 3. This is the equation that goes with that graph. This is the equation that goes with that graph. Now what's the problem? If you didn't have a graph how could you answer the domain? If you have a graph, you ask yourself the question, how left to how right? And hopefully most of us understood that. How far left? -3. Everything greater than -3 or equal to is fine. But how do we look at the function and figure out the domain? I want you guys to go ahead and just skip one line, maybe two. We're going to talk about how do we deal with functions and how do we deal with the domain question, then we'll come back and we'll solve for it and make sure that you guys understand why it's -3. Hold on, did it should left 3 or right 3? X plus 3. Thank you that we're confused. Good job being confused, because you should have been. I had that +3 I wrote down still in my head. X plus 3, I apologize. We'll get right back to how to solve this in just 1 second, but pause. Get everybody fix the X plus 3 or else we're going to be in some serious trouble in a second. Okay. Pause. This is super important. Wait until we write down the domain problems then. I'm still teaching this to my calculus BC kids and reminding them of it. Like it's that important. I hit the wrong button. Okay. Don't worry, we're not reviewing all of logarithms today. For those of you that started stressing out, that's in parentheses. We're actually going to barely even write it. You don't need to write it if they scare you. The only ones you need to write are 1 and 2. The nice thing about domain is even though it's kind of hard because we have to solve for it, we can solve for it. And I can tell you a list of fewer than 10 things. It's really 1, 2, 3, 4, 5. There are 5 things that can go wrong with domain. If none of those 5 things are present, the domain will always be all real numbers done, unless they state something different. I can tell you, watch out for these 5 things. Now, I'm not going to tell you them all today. See, logarithms? Ooh, we're not doing logarithms. We're not reviewing logarithms, so we're not going to go into that today. But by the end of the year, you will have 5 domain problems. Whenever you have roots, there could be a problem. Whenever you have denominators, there could be a problem. Whenever you have logs, there could be a problem. Whenever you have trig, well, I guess we could count those separately. But any trig with asymptotes, any trig with denominators, which is really number 2, but we put it in a separate category. Any trig with denominators could have problems. And then last but not least, I'll just say piecewise functions in general could have problems. Okay. I want you guys to write down the following. What I'm going to show you is a formula, a process, steps for what to do when finding domain if a root, an even-powered root, is present. Okay? So whenever you have any kind of root, that's a radical, right? Any kind of radical where n is even, so it could be a square root. You guys have seen the cubed roots. It could be a 4th root. It could be a 6th root, an 8th root. Anything where n is even, we could have trouble. Underneath the root, there might just be an x, but I'm going to put an f of x because there might be something more. There might be an x plus 3. There might be a 2x minus 1. There might be an x squared minus 10. So that one's missing. Whatever is under the root. And for those of you guys that like the boxes that we put around the x's and the y's, I'm going to put a box around this too. It could be long, it could be short. Whatever is underneath the square root, and just for you guys to know, just because it's sometimes hard to see where square roots end, I usually put a little tail on mine just to say, hey, that's the end of the root. Like in your calculator, the root keeps going. If you have a nice new one until you push the arrow, then it stops. That's kind of what my little tail does. But for domain, if n is even, then we can say for the domain, you're going to take f of x. You're going to set it greater than or equal to 0 and solve. Technically in solve, give myself a little more room. I'm not by taking it. Technically solve for x. So you take whatever is under the root, you set it greater than or equal to 0, and then you solve. You simplify. You solve. We'll talk about the y in just 1 second. Let's go ahead and talk about denominators. Denominators. What if you have a fraction, and in that fraction you have a function on top, and you have a function on bottom. You're given a function on top, you're given a function on bottom. For domain. That's what we're answering, for domain. We look at the bottom. That's where the problem can happen. In roots, it can happen under the root, in even-powered roots. In fractions, it can happen in the denominator. For domain, we take whatever is in that denominator, however long or short it is, whether it's one piece or multiple pieces. We take that one term and we say, you are not allowed to equal 0. Instead of saying where he does work, which is infinitely many places, we tell or we identify the one place he doesn't. We set him not equal to 0, and, just like we did above, we solve for x. I'm going to show that box again. So whatever is in the denominator of a fraction, if it has variables, we have to take that expression, set it not equal to 0, and then we have to solve for x. If you follow these two tricks, at this point, before we get into logs and other crazy stuff, if you see a root, you use this trick to find domain. If you see a denominator, you use this trick to find domain. And if you don't see either, you say all the numbers, I'm done. Unless they give you a graph where you have to, well, not even think about it for a function. Or they give you ordered pairs, and we'll see an example of that in just a second. So let's take this. Chris, hang in there. Let's go ahead and apply it to the last problem. Let's go back to the last problem. Oh, hold on, pause. I forgot. Question. I was going to ask after I wrote them. Why can't he be 0? You're not allowed to divide by 0. If you do, it's undefined, right? Nothing, 0 times nothing will ever equal a number. That's a good way of putting it as to why that's true. Why can't, or why must, what's underneath an even-powered root be greater than or equal to 0? We're not allowed to have negatives under the root because otherwise, what are negatives under a root? What kind of numbers are imaginary? We're not allowed to have imaginary numbers in order to have a real answer. Okay, I was looking back at this problem I gave you. Half of x equals 2 plus x, square root of x plus 3. Where is the problem if I'm trying to find domain? Square root. Is the 2 a problem? No. Ignore him. He doesn't care. He doesn't care. He doesn't matter for domain. I'm looking right here. I'm going to draw a box around him for those of you that are more visual. I need to take that function underneath the root. Technically, we wouldn't call him f of x because f of x is the whole guy. We could call him g or h or whoever we want. But we're going to take him, and what does notes say as to what we're supposed to do to find domain? Good. Set whatever is underneath greater than or equal to 0, then solve, right? So what was in the green box? X plus 3. So we're setting x plus 3 greater than or equal to 0, and then we're solving. How do we solve? Subtracting. Some of you in the past have just kind of guessed it and been like, just forward. Yeah, 3, 2, 1, 0, all works. -1, -2, -3, -4, uh-oh. And then you could have figured it out that way. But if you just use this clue of the argument has to be greater than or equal to 0, then you should be able to, solving by x, get what you the two connect, the graph with the function. What the graph shows, does the function show as well, as long as you know how to deal with roots? Take what's underneath, set it greater than or equal to 0, because he's going to go graph. And solve. So, the graph, hopefully, if you can just get down the question, how left to how right, hopefully the graph isn't super hard. But, even though the graph hopefully won't get too hard, I'll, for those who might pass the board. talking about domain. The function doesn't have to be hard either, as long as you carefully solve. Let's go see if I have any more examples. I think I do. I have a few. I want you guys to try your best to answer these ones. I'm not going to give you tons of time, so there's a couple more things to do. I would love for you to kind of collaborate as a whole class. But let me give you 30 seconds maybe a minute to get them all written down. Skip just one line each. You should have plenty of room to skip one line. Maybe 2 lines for B and D. For the sake of time, we're going to work through them as soon as you get them written down. Maybe you should be thinking, what am I looking for? Especially on B and D. A and C are a little funny. Actually, I'm going to add one more random one at the end if that's okay. Just to solidify the idea a little bit. Let me turn off the light for a second. My contrast on my projector is kind of funny today. My suspicions of being in the computer, so things are a little bit light. Just try to make it. So if you get the questions out there, so then you have time to think it out. So we'll be working on together. A is a collection of points, it's a relation. I think it's even a function. No x's are repeated with different lines. B is a function and its equation form. C is a function but not with x and y. D is a function and equation form. And E is another function and equation form. No graphs, although I guess you could try to look at a graph if you needed to. I know in Algebra 2 they didn't let you use the calculator all the time. And in Precalc, to be honest, I let you use it even less. Oh, it's okay. If we're getting stronger than material, we don't need it as much. We didn't need your calculator a lot in Algebra 1. Algebra 2, you wanted it all the time. Precalc, we gotta get better at stuff so we don't need it. Alright, letter A. Set of ordered pairs. Domain. All the possible which values? Domain x, right? X values. Well, how many x values, how many points do we have? Jillian, I think we only have 5. I think we have 5. Okay, so we only have 5 points. How many x's do we have? Only 5. And does x come first or second? First. So what are the x's that you're going to see? Just -3 and -1 and. How do we get those? Just each of the x's and each of the points. Those are the only x's that we have. So all the possible x values in letter A, well, there's only the 5. That's it. That's all we got. 1's not there, 3's not there, and 3.9999999 is not there, and neither or any of the other in-between values. Okay, that's it. That was as hard as letter A was. They only give you a certain number of points, and those are all the x's that you can possibly have. Now letter B is a little bit different. This is an equation where x can be anything. Plug in 1, plug in 10, plug in -11, plug in 37, plug in -723. I don't care. But is there a problem that can occur when saying x can be anything? Look at your domain problems. What's the problem that's present? Don't tell me that. What's the problem that's present? Denominator. And when we have a denominator, what do we need to think about for domain? The denominator, look at your notes, cannot be 0. Straight out of the notes. Whenever you see a denominator, take whatever is in the denominator, say that that denominator is not allowed to equal 0. And then, what do the notes say? Oh. Good. And I know some of you have gotten so in the habit of being able to see this that you were able to shout out the answer really quickly, and a few of you tried, and I was like, no, stop. Because if it gets harder, I need you to still know the process of what we're trying to do. We're trying to find the zeros of the denominator. And if there are multiple factors, multiple things being multiplied, the zeros of each factor in the denominator. So what do we end up with after we subtract 5 from both sides? X is what's left on this side. Does not equal or cannot equal 0 minus 5 is negative 5, right? Specifically in this one, if x did equal negative 5, we would have a vertical asymptote there. It's non-removable since there is no x plus 5 in the numerator. But if you did not follow with any of that extra information, we'll get to some other day. Letter C is a bit more complicated. Letter B was an implied domain. Letter A was a given. They only gave us 5 points, so okay, whatever, that's our domain, we're done. Letter B was implied, but using our tricks on the page before, we were able to say, sweet, denominator, got it, done. Okay, we're good. Glad you were crying, but it wasn't that scary. Letter C. Sometimes real world dictates what the domain is, and that's an example of this one. Because can we see spheres in the real world? Yeah. You can see a lot of math in the real world, but you guys probably can't really recognize all of it. But spheres, geometric figures, okay, yeah, sphere, a ball, there we go, got it. R stands for what with that equation? Radius. Okay. What kinds of numbers would it make sense that a radius could be? Or maybe better yet, what kinds of numbers would it not make sense for a radius to be? 0. Negative, yeah. How can you measure radius? Radius is just a measurement, like it's no positive, negative, it's a ruler, no. Okay, so R's can't be negative, but what else could an R not technically be and still make a sphere? 0. It can be positive numbers, sure, you have a little R, a big sphere, little sphere, right? But if R was 0, what kind of sphere is that? It's a point. A dimensionless point, that's kind of lame. And if R is negative, well, we have like a black hole thing, I don't know. Anyway, so, long story short, R is greater than 0, and that is implied in the context. So only every now and then you have to think about real world context. Oh, well, yeah, radius is only positive numbers. Okay, that was a weird one, so I'm going to throw one weird one out at you. That's not so much based on the equation or on the graph, it's based in the real world. Letter D, where's the problem? Okay, so take it. And you've seen me already model it. What am I going to do with it right now? Not equal to. Greater than or equal to, right? And then what are my directions after you take what's inside and set it greater than or equal to 0? So I'm going to subtract 4 from both sides. That's going to get me to negative 3x greater than or equal to negative 4. I didn't really have a lot of room below, and some of you realize when you do equations and you go down, it's really hard to like use the lines of your page. Which hopefully if you're in homework, you would fold the page in half and have 2 nice columns and then use, some of you that like do your problems all over, it's awful. Stop doing that. But coming back, you can also have your work go to the side sometimes. How would I solve for x? Divide by negative 3. Ooh, inequalities. What happens when you divide by a negative? Well, it does cancel out. It reduces. But you change the inequality. It flips, right? So now x is less than or equal to, what's a negative over a negative? Positive. So I have 4/3. My domain is x less than or equal to 4. You didn't have to guess, you didn't have to experiment, you didn't have to plug in different numbers, you just take the clue and say, oh, square roots, argument must be positive or 0. Put that in a math statement, solve. Last but not least, letter E. Ooh, the hardest one. Or maybe the easiest. I heard it, say it louder. Why is it all real numbers? It's so nasty. It has a 15 and an x cubed and all sorts of, like 11x and a 7 and some negatives.
There's no limiting
Oh, it's on YouTube, that's very cool. Here we go. Is there a denominator? With an x in it? Nope, the denominator is just over 1, I guess. Is there a root? No. Is there a context of a real world problem? No. All the numbers are done. No square root, no denominator. Eventually, no logarithms, no trig. All real numbers, done. Domain, not super hard. Range, a little bit tricky. As you guys are writing down range, we are going to have to take half a day to finish this tomorrow, and that's okay. Section 1.4 is kind of a beast. Some of you, it's easy stuff, but for others, it's kind of all their fears in one. We have fractions, we have domains and ranges, we have word problems. At the end, we're going to have function notation, and poor little animals are going to be killed by just you guys naturally doing what you think is right. Especially puppies. The puppies are the ones that are going to suffer, and the seals.
That's just.
Well, that's why you shouldn't do bad math. Okay, so, quick heads up. This homework is not going to officially be due in its entirety until Thursday, because today's Tuesday, right? But, just a warning, we are starting, hopefully, section 1.5, second half of tomorrow. So, we weren't able to get this started last night because we didn't cover a lot. We have covered a lot more. We get a good start in on it tonight. So you guys can and then today that I was talking for an hour and a half, so we'll likely use our next day. But tomorrow you will for sure.
Oh my god.
No, because the 5 took me 2 hours. I ended up taking a route through to get to the 14.
I know that.
Your highway was even worse.
No, I remember, so I'm talking about my work. I work in the thing, and sometimes the streets close down and the freeway also closes down. So literally was just 25
See, it wasn't closed down, but everything was jammed, so then everything else was like all of St. Peter was ready.
True, I know that feeling. At least we got to safely
Yeah,
finally.
And like 8:03, that wasn't bad.
Hey, good job.